Yeah. So good afternoon, everyone. Hope you are enjoying the talk. My name is Alok. I'm a front-end engineer at Cashfree. This is my little introduction. With that, let's get started with our today's discussion. Scripting the serif. That means how we can use or manipulate font for the better performance of our web page, right? So let's first discuss with the basic, like what is font? So font is a collection of characters, including symbols, number, or special characters that is designed in a very different, different style that can be consumed over different digital media. So whenever I use this term, we came across these two terms, font and the web font, right? So what is the difference between these two? So font is a, you can say, a broader term, which is not only limited to uh, browser, but can also be used across other platform like desktop, the graphic engine and all. For this font, if you want to use it for the other areas, you have to download it first. Like if you are using Photoshop and you want to use any font, you have to download it first before using it, right? But in case of web font, you don't have to download it. It is done by browser as a part of browser resource, right? So this is the difference between font and the web font. So in this talk, I will be mainly focusing on web font. So whenever I'm using font, that means web font. Now we know what is font. So how do we define font, right? So for this, we have this CSS rule called font face. This helps us to define font. So as you can see in the snippet, I have written at the rate font face with font family and source, right? And to use that font, I have applied font family to the H1 tag, right? So font in the font face, you see font family. So font family will define the name of your font, and source will tell the browser from where it will be fetched, right? So now let's discuss this font family thing, right? How it is different from font face and how it is linked, right? So font face is basically helps you to define your font, right? You can define it, but font family is actually applying those font to your element. So this is how we define font, but where can we use it, right? So there are two ways of adding font face. The first one is either you can directly inject in your head tag in the inline style, or the second one is you can use external style sheet, right? Which is a better way to include font face? Of course, the external style sheet, because it is easy to maintain, right? Well, for a larger code base, it is easy to maintain external style sheet rather than the inline. And the second benefit is, uh, in case of external style sheet, it is being cached by the browser, right? So whenever the browser parses your HTML, uh, it first download the CSS and then parse it and then load this font, right? Whereas in case of inline, whenever browser encounter this font face, it start downloading this, it start downloading the font from this URL. For external style sheet, as we have downloaded and the CSS first, downloaded and parse it. So for the initial visitor, it will be less performant for the first time. But for the second time, as it is being cached by the browser, so it will give a better performance for the subsequent visitors. But in case of inline, since it cannot avail the advantage of caching that is provided by the browser, so for the first time, as it remove the downloading and parsing of the CSS, right? But it misses the caching advantage that is provided by the browser. So and also maintaining CSS in inline style is very difficult. So now we know that external style sheet is a preferable way of adding font face. Now, how browser parses your HTML and then using it, uh, using the font, like applying the font to the HTML, right? So first of all, whenever we hit any URL, browser requested for the HTML page, browser start parsing the page from top to down. So first of all, while parsing, it encounters that we have this CSS resources as well. see, along with the JS and all. So it start creating DOM and CSS OM. Uh, so I will mainly focusing on the CSS OM thing. So while creating the CSS OM, browser will come to know that, hey, we have defined this font, like the developer have defined this font face. So now I will register it, but it won't load the font face, right? I will tell you why. So at the point of CSS home, our font face declaration is ready. Browser know that we are going to use any font in our HTML page. So the next phase is render tree. So uh, now the linking between DOM and CSS OM is started. So here browser come to know that some element is using this font. So at this point of time, browser will start downloading this font. So that means declaring the font won't trigger the download, but using that font will trigger the download, right? So this is how browser parsed it. And this is a like a happy scenario, right? We browser requested the font, download it, and then display the content. But what will happen if there is a delay in font face loading? So how browser handle this font delay? So different browsers behave differently. Like Chrome, Edge, and Firefox will behave similarly, whereas the Safari is opposite to it. In case of Edge, Chrome, and Firefox, it will hide the text for 3 seconds. Like it won't show anything on the screen. But if the font is ready during this time, then it will show using that font. Otherwise, it uses your fallback font or a system font. Like if you provide any fallback font, then it will use that. Otherwise, it will use system font that is different, like vary from system to system. And till since the font is now, like the content is now displayed using system font, behind the scene browser will keep fetching the font. If it gets ready, then it will immediately swap out the font. Whereas in case of Safari, it will hide the font it will hide the text until the font is ready. It will not show anything on the screen, right? But what what if we want to tell browser that behave according to me, right? So for that we have this property called font display. It is a font face uh, property uh, that tells the browser how you should behave when there is a delay in font. For this, we have, for font family, we have 5 value: auto, block, swap, fallback, and optional. I will go each and like every value, like how it instruct the browser. But let's first understand how browser uh, uh, breaks down the font display. So for displaying font, browser delay this period using into three period. The first one is block period, the second one is swap period, and the last one is failed period. So as I told you in the HTML parsing slide, that whenever browser start requesting font, it immediately entered into block period. And so I'm talking here about only the default behavior of browser. So whenever browser requested the font, it immediately entered into the block period and wait here for 3 seconds. And nothing will be shown on the web page. And behind the scene, browser will keep fetching the font. If font is ready, then the text will be displayed using our custom font. Otherwise, it will be shown using system font at the end of this period. When this period ends, it will immediately enter into the swap period. So at the starting of the swap period, our content is ready using the fallback font or a system UI font. So now, since our content is displayed using font period, but behind the scene, it will again keep fetching the font. If it is ready, then it will be swap out. Otherwise, it will move into the failed period. And if any request moved it to the failed period, then that font is marked as a failed, right? So now your content will be only shown using your fallback font. So now we have a fair knowledge of how browser like break down our display of font. So now how we can instruct browser to behave according to our font display value. The first one is auto. Auto is again the default behavior of browser. The second one is block. In case of block, you will get 2-3 seconds in the block period. and infinite time in swap period. That means for 2-3 seconds, if you use font display block, for 2-3 seconds, nothing will be shown on the screen. After that, if font is ready, then it will be the font, our custom font will be used. Otherwise, this fallback font will be used to show the content. Once this period is over and the font is still not ready, then it will move into swap period. And it gets infinite swap period. That means your content will be shown using fallback font, but behind the scene, it will keep fetching for the infinite time. Once that font is ready, it will swap out. The third one is swap. It will wait for 0 millisecond. That means it has zero block period, 0 millisecond block period. It immediately enters into the swap period. That means it will show you content using your fallback font. And behind the scene, again, it will keep fetching the font and then it will show it. In case of the fallback value, it, it has a very minimal time in block period, like 100 millisecond, and then 3 second in swap period. Once if font is not ready during these two period, that it immediately move into the failed state and your fallback font will be used to show your content. Whereas in case of optional, there is like just 100 millisecond in the block period and no swap period. That means if font is ready within 100 millisecond, then your content will be shown using your font. Otherwise, the fallback font will be used. And after the block period, it immediately entered into the failed period. Uh, so this is how we can control the display of font. But let's discuss the caveat with the font loading and rendering. The first one is delay in font loading. There are various reasons involved in this, like server issue or anything. The second one is large font size. If you try to load large font size on the initial parsing, it will immediately lead to the first point, right? The third one is invisible text rendering. It occurs like as I shown you in last slide, that in case of block, it will wait for 2-3 seconds, right? So this generally occur this problem in visual text rendering. Like for the 2-3 second, user won't be able to see anything on the screen. So this causes this problem. The fourth one is flash of unstyled text. Like who is responsible for this? The swap. As you can see, there is 0 millisecond time in block period. That means it will immediately show the content using fallback font and then uses the font. So like there is a high chance that the size or format of fallback font is different from your custom font. And all these four problem leads to this last one, that is core web vital. Like if there is a delay or large font size or invisible text rendering, that will immediately that will directly hampering our core web vital, like largest contentful paint, first contentful paint, or cumulative layout shift. So we have to understand like font resources are very important. Like without it, we won't be able to see anything on the screen. So to optimize it, it is our duty to optimize it, right? To get the better user experience and performance. So I will discuss in points. The first one is effectively use font display. So there is no hard-coded rule that this is the value you can use to show the font that is optimal for you. So I have created this table, trade-off table, which you can use. Like if performance is your top priority, then you can use font display optional. So in optional, in the last slide I shown you, in optional there is a very minimal block period, and then it will immediately enter into the failed period. That means your first contentful paint will be very fast, right? It will be just 100 millisecond. If displaying text quickly is your top priority, then you should, but you want to still ensure the web font is used, then you should go with the font display swap. Because in swap, there is no block period. That means your content will be shown immediately using the fallback font. And then behind the scene, font, your custom font will replace it, right? If custom font is ready. For the third case, if ensuring text is displayed in web font is a top priority, then you should go with font display block. As you got 2-3 seconds in the block period, that means nothing will be shown on your web page till the font is ready. The second one is use size adjust to minimize CLS, right? If you use font display swap, right, so it initially it will show content in fallback font. So there is a very high chance that size or format of the fallback font is different from your custom font, right? So this size adjust, and that will cause cumulative layout shift. Like if font will be swap out, that will cause layout shift, and that will hamper your user experience. For this, we have this again a font face property called font adjust. So as a like developer, we know like what are the like what can be the differences, how much our style is different from your our fallback font. So for this will basically adjust your uh, custom font size according to your fallback font. So here I have used font adjust 120%. That means uh, our custom font size is smaller than our fallback font size. So I have increased the size to 120%. And in the H1 tag, like I have added font family web special font, and then I've added sans serif. Sans serif is our fallback font, right? So if sans serif is also not loaded, then the system UI font will be used. The next one is how we can reduce font loading time. Uh, this is again like this is a top priority task that we have to do to reduce the font loading time. The first one is preloading font. So preloading means even before creating our DOM and CSS DOM, we can load our font, right? So whenever our render tree will be created, this font will be available there. But there is one caveat associated with it, like preload will hamper the loading of other resources as well, because this will be given top priority, right? So if we have a large font size, large file size, then it will hamper the overall loading of our web page. So for using this, we can use this link tag with attribute rel is equal to preload. Uh, so whenever browser encounter this thing, it will start loading our web font. But use it wisely because it can hamper the overall loading of our web page. The second one is pre-connect to the font origin. What does that mean? It again uses this same link tag with rel is equal to pre-connect now. So what it does, whenever we start parsing our HTML, it discover this link tag, and browser will know that I have to connect to this web font URL, but it won't do anything. So it will do the basic thing, like it will connect to the server. Like if we are using HTTPS, like DNS, like DNS lookup, handshake, all thing will be done like pre-creation of our CSS OM and DOM. So whenever our CSS OM, like our render tree is created, so browser came across this font family that I have to use this. So at this point of time, browser know that my setup is already connected. I just have to start downloading the process. So we have reduced our initial setup, initial time. So this is how we can delay, and this is the like, best way we can do it, right? The pre-connect. So it won't hamper our overall loading of web page. The last one is we can cache, since browser resources are kind of a static resource. Like it is very unlikely, like it is very likely to make a change in browser file, sorry, in a font file. So we can provide optimal cache policy, like we can increase the max A size or a proper ETEC header, right? And the second one is if you are using web service worker, then you should serve your font resources with cache first strategy. That means you should serve your cache, so sorry, serve your font from the cache and then hit the URL. So this will reduce the load time, right? So these are some method to reduce the load time. Now let's move to reducing web font size. So for reducing web font size, the first thing we can do is we can use this two compression algorithm, WOF and WOF 2.0. WOF means web open font format, and the 2.1 is a advanced version of WOF, and it is widely used across, like widely supported across all the browser. So in WOF 2.0, it uses broadly compression, and it is 30% better than WOF, the legacy one. So we can go ahead with 2.0, and you can see also see in my code snippet that I have used WoW 2.0 uh, for every URL. The second one is uni-range subsetting. So this is kind of interesting. So Unicode range, you can think of it as a filter, right? So let's say you are creating a web page with two like I have used this basic Latin and Euro symbol. So let's say your initial page uses basic Latin. So so browser supported this Unicode range, like so it basically bifurcated your font file into so into two format. Like one is a Latin basic and special symbol. So I've created two font face, right? For one for Euro and one for basic. So whenever our browser encounters any uh, element that uses basic Latin, right? So first of all, it will look at the Unicode range. If that range, like that element text is basically included in this range, then it will download that start download the URL, and it will not touch the second one. And for if any page contain the Euro, then it will start downloading the second one. So we have basically reduced our font, like we have divided our font file into two, right? Oh, but what will happen if uh, font is uh, both font is used in our initial page? Then the order of loading is dependent on which content comes first, right? If Euro symbol comes first, then the second font space will be loaded. Otherwise the first URL will be hit. And also you have noticed that I have added local here, right? Uh, yeah, sure. So I have added local here. So what does this mean is, like, first of all, try to search your font from local, right? And then go to the server, right? So if it is present, which is very unlikely that a font is available in your local system, but if it is present, then you can drastically reduce your uh, font delay problem, right? If it is present, then there is no need to then browser won't hit your server. So these are the two techniques for using it. You can reduce the web font size. So yeah, that's all from my side. Thank you so much, guys.